All right, good morning. We're back in action after a hiatus, a brief hiatus. Well, I thought we were back in action yesterday, but technical difficulties, we'll say. That's right, yeah. Dude, I wanted to cry. That was so awful. I could not believe. I've never been so disappointed in myself. I was literally talking to myself for over an hour. Because, I don't know. I don't even have a good reason. I mean, I did recognize, nobody was saying anything. But, I don't know. Depending on the day, sometimes you guys really don't say much. Usually there's at least some chatter. But, I don't know. I was kind of tired too, so I think I was just kind of going for it. I was just like, all right, let's just go through this and get it done. And, I don't know. It never really registered that overall nobody had talked. I feel like I was just every time I would look in the chat, I was like, all right, no new questions. But I never put it together that hey, there's been no new questions or any comments for 30 minutes. I don't know. I don't know. I just sat here like this for, I don't know, maybe 5 minutes, just contemplating all my life choices that have led me to this moment. It was harsh. What a moment to join. I feel like I still looked like, I remember at one point, or at least at a couple points, I had noted all right, nobody's saying anything. But if I clicked on the users in chat, at the top right, there were people that were in the chat. And so I don't know if that was just people who had just left the stream open, to see if I would eventually start it or whatever. But so when I saw that, I was like, okay, yeah, there are people here. They must not be saying anything. So I don't know. So it's been a rough couple days in this class, especially paired with Friday. I couldn't get my mic to work. I did get it working eventually, after an hour of just messing with stuff. But we've had tough times in this class. So let's actually try to teach this lesson, which I've been trying to teach since Friday of last week. And I did teach yesterday. So the good news is I already did all this yesterday. I already taught all of it yesterday. So hopefully I'll only just be mildly garbage at teaching it today instead of utterly atrocious. That's the hope. It's just practice, man. Practice makes perfect. Okay. All right. Well, let's do this. Reminder that on Friday I sent out the email. I think it was Friday. I sent out the email about making sure to let me know if you do or do not want to still take the BC test. Just try to let me know before this Friday. I've had several people respond to me already, but I need everyone's response just so I can say for sure to administration, yes, these people are still taking it or these people are not taking it. Yep. Okay. All right, let's do this. Let's finally do this. I don't know what's going to go wrong today, but let's at least try it. All right, workers at a local office building are expected to be at work by 9. Let the twice differentiable function y equals w of t be the amount of workers in the building at time t in minutes, satisfying the logistic differential equation dy dt equals 115y, 1 minus y 100. Okay, so first off, just noting, it straight up tells me, I don't even have to recognize the formula, it tells me this is a logistic differential equation. So logistic, I don't know, you might remember, this is like the general formula for that. All right, and we can see that this is actually even in that perfect form. We don't even, sometimes with these forms we had to like factor or do some manipulating, but this is just straight up in that perfect format, except for instead of capital P, it's Y, or whatever. W of 0 equals 2. T equals 0 is 8 a.m. So I have a table of values for W. Great. So first up, I want W prime of 65. Right, so something to note here. Right, so W of t, so W prime means 60. When t is 65, what is W prime? Well, W is the same as Y. Okay, so what's the derivative of W? That's the derivative of Y, but we already have an equation for the derivative of Y right here. So W prime of 65, that's the same thing as saying, okay, well, what is dy dt whenever t is 65? Okay, but here's the interesting thing. So I think kind of the most common error I might see here is people would just plug in 65 for y. They say, okay, my variable is y, so I'll plug in 65 there. But that's not what this says. This says that t is 65. Right, but this is y. Okay, so I don't want to plug in 65 there. What I actually want to plug in, right, if t is 65, then y, or w, is 60. So actually what I'm plugging in is that y equals 60. All right, so I have to be careful about that, about what we're plugging into this equation. So 1/15, 60, 1 minus 60 over 100. And then just simplify. 60 over 15 would be 4. 1 minus 60 over 100, so that would be 40 over 100. 40 over 100 would be 4/10. 4/10 would be 2/5. So W prime of 65 is 8/5. All right, now I want W double prime. W double prime. Yikes. Okay, so I need the derivative of W. Well, another way, I need the derivative of W prime. Well, W prime is the same thing as dy dt. So what I'm going to do is I'm going to take the derivative of this. All right, so that I get the, let me write it like this. So first I'm just going to do the derivative. I'm not going to plug in 65 yet. So W double prime of t is the same thing as d squared y over dt squared. Okay, which is what? So let's take the derivative. This 1/15 out in front, I'm just going to leave as a coefficient of 1/15. I'm actually going to pull that out so I don't have to worry about it. And note here, if I just leave this as is, then I have one function, two functions that are being multiplied together. So if I'm trying to take the derivative of two functions that are being multiplied together, product rule. first times derivative of second. So the first is just y. The derivative of 1 minus y over 100 is just negative 1/100th. Plus the second function times the derivative of the first. Oh, wait a minute. Hold on. I forgot something. This is a function that we're taking the derivative with respect to t. But then if I'm trying to take the derivative of y, it's not just negative 1 over 100, but then chain rule, right? This is implicit differentiation, so I need that dy dt on the end. Right, now plus the second function, 1 minus y over 100, times the derivative of the first function. So the derivative of y is 1, but chain rule, so dy dt. Okay, there's my function. All right, it's pretty messy. Now let's go through and plug in 65 for t. So that's the same thing as evaluating if t equals 65. But again, look at my equation. There is no t in this. There's only y. Okay, so actually, but I know that if t is 65, then that means that y should be 60, right? We know that from our table. So we'll go through 60 negative 1/100th dy dt, if y is 60, we already know is 8/5 plus 1 minus 60 over 100. So that would be 40 over 100, 4 over 10, 2/5. dy dt, again, if dy dt, whenever y is 60, we already know is 8/5, so 8/5. If this were the BC test, don't even need to simplify it. Just stop there. Okay, unless you need to use this number later on for something else, like if the question just asks for this, well then great, just leave it. Don't do the calculations. Okay, you're only giving yourself a chance to mess up. If we went through and actually did the full, whatever, we would get negative 8 over 375. Right, if you simplified it all the way. Okay, so that's the second derivative. Using correct units, interpret the meaning of the second derivative of w in the context of this problem. Okay. So let's first think, just w, you wouldn't need to write this out on the AP test, but I'm just writing it out to think about what this means. W is the amount of workers in the building. Okay. So W prime, right? Is that the words they used? Amount of workers in the building? Yeah, okay. Amount of workers in the building. W prime okay, W prime is then, so when we take a derivative, remember that represents a rate. So W prime is the rate of the amount of workers in the building. So like, is the rate positive, so the amount of workers is increasing? is the rate negative, so the amount of workers is decreasing. Okay, so then W double prime is the rate of amount of workers in the building. Okay, so remember, if you're trying to, good morning, if you're trying to go through and determine like what does a derivative represent, well, what does the thing above it represent? You know, above. So like W represents the amount of workers. Amount of workers in building. So W prime is just the rate of the amount of workers in building. So W double prime is the rate of the amount of workers in building, right? You can really just put the rate of in front of whatever the thing above it was, and that's, you know, what it represents, right? The rate of the amount of workers in the building. And the third derivative would just be the rate of the amount of workers in the building. Okay, so I think this helps give us just kind of a basic idea. Now we have to be more specific. So actually W prime of 65, so if T is 65, you know, so interpret, so I don't just have to say what it is, I have to give meaning to it in the context of this problem. So this means, right, let's look at it. The rate of the rate is first of all negative. So when I take a derivative and I get a negative, that means the thing above it is decreasing. Okay, so that means that, so doing W double prime, getting a negative value, tells me that the thing above it is decreasing. So W prime, so what this means is the rate of amount of workers is decreasing. Decreasing by how much? -8 375ths workers per minute All right, remember, we need that double per minute on there because we're talking about a second derivative. So remember, this part here is just saying double W prime. Since the second derivative was negative, that tells us that the first derivative is decreasing, which is what we said, right? So this means the first derivative is decreasing. Well, decreasing by how much? Well, let's just say whatever the value is, and then give the units. Workers per minute, since it's the second derivative. All right, and then same thing again for the third derivative, it would mean the rate of the rate of the rate. And then if we were talking about interpreting it, we would say whatever the number is, workers per minute. You just keep adding this stuff on. Perfect box around my answer. Believe it or not, this was much better than my explanation yesterday. Part B. So this is the same setup. I just copied it over onto every page. That way I don't have to flip back and forth between pages. I finally realized that sucks. Evaluates the integral from 0 to infinity of W prime of 3t plus 25. Okay. So first of all, when I see an integral that has infinity, I'm automatically thinking I'm going to need to do an improper integral. All right? So let's write here. Show the work that leads to your answer. Okay, great. So we just have to evaluate it and just show our work. So 0 to infinity. I'm just going to copy this down again. dt. Now again, we don't really like having the infinity in there. So let's use a replacement variable like b. So the limit of 0 to b of w prime of 3t plus 25 dt. So now let's go to this integral. Now remember, w prime, if I want to take the integral, what's the antiderivative of w prime? W, right? So the antiderivative of w prime is just w. Now I would just put w here, except we have this 3t plus 25 in here, so I kind of have to consider like a reverse chain rule. So normally, I might just say, okay, the antiderivative of w prime is just w, so great, just take w, evaluate it at b, subtract w, evaluated at 0. But we have this 3t plus 25 here, so what that means is I would need a 1/3 here. That's basically, that's one of those quick u substitutions, right? Because think about it. If we take the derivative of this, so our derivative of w is w prime, and then chain rule, take the derivative of the inside. So wait, 1/3. So take the derivative of the inside, so then times 3 at the end, so that cancels the 1/3 and the 3. Which just gives us w prime, which is this, or w prime of 3t plus 25. Oh no, not forward. Okay. Oops, I forgot to write my limit. So now let's do our evaluation of the integral. So 1/3 w of 3b plus 25, right? Plug in the upper bound, minus 1/3 w of 3 times 0, which is 0 plus 25, so w of 25. I'm going to go ahead and pull out the 1/3. We can do that with limits. Right? Factor out a 1/3 and then move it in front of the limit so I don't have to worry about it. Now w of 25 we know just from the table. Right? If t is 25, then w of 25 is 10. So I know that's just going to be minus 10. Okay, so the only unknown here is what is w of 3b plus 25 as b goes to infinity. So here's where we have to know stuff about our logistic curves. Right, as b goes to infinity, so basically as this whole inside goes to infinity, as I plug in larger and larger and larger and larger numbers, what will happen to w? Well, think back to this formula. M represented something really specific. Right? I don't know if you remember, M represents the carrying capacity. Right? If we were talking about population, but M is sort of like the maximum. Right? What's the most amount that there could be? So for this equation, M is 100. So it doesn't matter what I plug in or how large, how much time goes on, the maximum that it's going to hit is 100. So as b goes to infinity, the largest that this whole term can get is still just 100. So that limit is 100. Okay, so that's just 1/3 then. 100 minus 10. 100 minus 10 is 90. 90 times 1/3, or 90 divided by 3. It's 30. All right, so that's just knowing improper integrals and logistic curve properties. All right, I still have everyone here. I didn't, click stop streaming or anything. I got to check now. I got to do. Part C. Same setup. Use a left Riemann sum. 3 subintervals. Approximate the value of 1/45th, the integral from 0 to infinity of w of t. Explain the meaning in the context of the problem. All right, so first let me just figure out what the heck this is by using a left Riemann sum. So we don't actually have a function for w, so I can't just integrate it like on my calculator or by hand or anything, but I have a table of values for w of t. So what we can do is we can use the Riemann sum, which is a rectangular approximation. So it says from 0 to 45, so starting at 0, ending at 45. And we're using a left Riemann sum. So my first rectangle will start, the first point that I use starts here on the very far left. Okay, that's important. And then my second rectangle will start, the point I'm going to use for the height is here. My third rectangle, I'm going to use this value here. So I should not be using this 30 anywhere in my equation. Okay, I'm only going to use the 2, the 10, and the 13, right, the left sides of it. If this problem had said use a right Riemann sum, if it was the same exact problem except it just said use a right Riemann sum, then I would start on the right. I would be using these 3 points. All right, I wouldn't end up using this 2. Okay, and I would end up using the 30 here. So it's very important that we're paying close attention to left Riemann sum versus a right Riemann sum. Okay, but these are just rectangles. So this is approximately, so this 1/45th, I'm just going to leave out here 1/45th. Oops. Okay, so my first rectangle goes from here to here. Now, how far is that? It goes from 0 to 25. Great. So that base is 25. What is the height? Well, that first height is 2. So 25 times 2. Plus the second rectangle. So the second rectangle goes from here to here. So from 25 to 30. So the base is 5. What is the height? So I go to use this second height, which is 10. So my second rectangle is 5 times 10. My third rectangle goes from 30 to 45, so that's 15 as the base. What's the height? 13. So 15 times 13. Okay, you could leave this as is for your final answer. You don't need to simplify that. Unless you needed to use the number later on for something else. But if you actually did the math, you'd get 295/45. Now, however, it's not just find it. Remember, explain the meaning. So make sure you're following, not just finding an answer. Probably it'll ask you to justify or interpret the meaning or explain the meaning, in the context of the problem, something like that. Okay, so the key to explaining the meaning in this part is looking at this and recognizing this looks kind of familiar. This looks like a formula I've seen before. Right? Does this look familiar to anybody? What's this the formula for? I can only assume that my stream has stopped working, hence why nobody is answering the question. Sounds good. This is average value. Okay, so what does this number actually, or what is this, expression or this answer, what does it actually represent? So 1/45. Not A to B, sorry, 0 to 45. So what does this represent? It represents the average value of workers that arrived from t equals 0 to t equals 45. So from, what was t equals 0? T equals 0 was 8. Okay, was 8. So that arrived between 8 a.m. and 8:45 a.m. So 8 a.m. is t equals 0. 8:45 is t equals 45. How, why? Are you asking me how or why something about this problem? I'm so confused. Okay. Part D, use Euler's method with 2 steps for everybody. He's here. I've been here the whole time. It was you guys that left. Your guys' computers just suck, so it exploded. You really should get that fixed. Okay. So part D, use Euler's method with two steps of equal size starting at t equals 45. Okay, Euler's method, two steps starting at t equals 45. Approximate the number of workers inside the building by 925, so whenever t equals 25. Okay, so for Euler's method, we know we always make a table. So n. Usually I would do x, y, but instead I'm going to do t, w. I know my n is going to go up to 2 because it says 2 steps. So it starts at t equals 45. So that's my starting value. And I know for if t equals 45, then w is 30. So I have my starting amounts here. If we remember Euler's formula, so the first thing I need is my y1, or I guess, in this case, if you wanted to write w1, I don't know. Equal w0. But I'll just stay consistent. Let's just, again, if you want to think about this as x and y, it's whatever. It doesn't matter. Okay. But y1 would equal y0, right, plus dy dt evaluated at t0, y0. I keep shifting between variables. X, y, t, I don't know. My point is this column is either x or t, however you want to think about it. This column is either y or w, however you want to think about it. I'll use t and y. Right, times h. Right, now what is h? Well, we're starting at 45, we want to end at 85, and we want 2 steps. So h equals 85 minus 45 divided by 2. So that would be 40. 40 divided by 2 would be 20. So h is 20. y0, so my first y value is 30. So 30 plus h is 20 times, so what is this dy dt whenever t is 45 and y is 30? Well, we have a formula for that right here, so we can figure that out. We'll have to do some side work. Okay, dy dt whenever y is 30, so 1/15 times 30 times 1 minus 30 over 100. So that would be, let's see, what do we got here? So 30 over 15 would be 2. 1 minus 30 over 100, that'd be 70 over 100, so 7/10. So 14/10 or 7/5. Twenty times 7/5, so that'd be 4 times 7 is 28. 28 plus 30 is 58. All right. We're jumping from, remember, from 45, we want to end at 85, and we're jumping in steps of 20, so 45 must go to 65, and then 65 must go to 85. Okay, so now we know y1, let's find y2. So that would be y1 plus dy dt evaluated at t1 y1 times h, right? That's just the formula. That's just something you got to know. So equals, what's y1? y1's 58 plus h is 20. Now we just have to figure out what is dy dt here. Dy dt, whenever y is 58, so 1/15 times 58, 1 minus 58 over 100. So that would be 58/15 times 42/100. Let's see the simplification. Two of 3, 125ths. So that's what goes here. And we just finished multiplying, so taking that times 20 plus 58. Our wonderful fraction that we would get is this 2,262 over 25. Or as a decimal, that would be about 90.48. Okay, so that would be my final answer, right? That's all it asks. I don't need to interpret anything. Approximate, yeah, W of 85. So I guess if we wanted to fully write out, just to show, hey, this is an approximation, so W of 85 equals about 90.48. Could be good to do. Right, so Euler's method. Next up, is there a time C such that C between 25 and 45 when W prime of C equals 1? Justify your answer. Okay. The big keys here are, is there a time C? So it's not asking even what is the time C. It is merely asking for existence. Does it exist? Is there a C such that W prime of C is 1? And then the real emphasis here that's going to tell me what to do is that this is W prime. Okay, a lot of times when a question asks us, like, does there exist a value such that W is 1 or W prime is 1? We should probably be thinking of one or two things, either intermediate value theorem or mean value theorem. Okay, so how do we tell which is which, or how do we know which one to use? Mean value theorem is the one that deals with determining if there's the existence of the value of a derivative. Intermediate value theorem asks for or helps you figure out if there exists an actual value of just normal W. Okay, so intermediate value theorem is just of the normal function W or F or whatever. Mean value theorem is if it asks us about does this value exist of a derivative. Okay, so I'm going to try to use mean value theorem. So first off, for mean value theorem, we start by finding the average value, finding the mean value, the average value, right? Average rate of change. So W, I cannot write. I don't know what I'm writing. Okay, let's just stick with that. 45. W of 45 minus W of 25 over 45 minus 25. All right, so that's just the slope formula, right? Y2 minus Y1 over X2 minus X1. W of 45 and W of 25, so that would be 30 minus 10 divided by 20. 20 over 20 is, wouldn't you know it, it's 1. So if we can apply the mean value theorem, then we could say since the average value, right, the average rate of change between 25 and 45 is 1, then there must be some spot where the instantaneous value of C is 1. Instantaneous value at C is 1, not of C. All right, but we need to state a key thing here, is that in order for the intermediate or mean value theorem to work, we need to know that our function is continuous. Right? Is W continuous? That we can do this? Well, yes, and we know that because it tells us this function is twice differentiable. Right, twice differentiable and thus continuous. I guess on 25 to 45. So, by the mean value theorem, we have shown that there does exist some C such that W prime of C equals 1. So I was tipped off about using that because it asks me about, will the derivative ever equal this value? Right, and just trying to proving that it will or will not even what is the value, where is it equal to 1? Well, I don't know, but I don't need to know. It just asks, is there a time? So our answer is basically yes or no, but then we just have to have some justification. And our justification is the mean value theorem. Okay. F, let P2 be the second degree Taylor polynomial. Centered at t equals 65. Oh, that reminds me. The AFA Taylor polynomials, Taylor and Maclaurin polynomials is available to be taken. It's not very involved. It asks you to find some very short Taylor polynomials that are multiple choice. Okay, and then just asks a couple questions about properties of Taylor polynomials. So you know, we always try to, if we're trying to approximate a certain value, we want to center that polynomial close to the value, right? Or the larger degree of Taylor polynomial, the more accurate it'll be, right? So that's kind of two ways we can control accuracy of the approximation, is either making the degree larger and or centering the polynomial as close as possible. Okay, so it's some pretty not super detailed questions about Taylor polynomials, if you're ready to try that. But anyways, so find the second degree Taylor polynomial and use it to approximate whenever t is 85. All right, so first let's just figure out P2 of t. So the second degree Taylor polynomial. Taylor polynomials always start with just the function. So in this case, w at wherever it's centered. So this one's centered at 65, so w of 65. Okay, plus, now we're just headed into that pattern. So w prime of 65 divided by 1 factorial times x minus 65 to the first plus w double prime of 65 over 2 factorial x. Well, I guess I shouldn't use x. I should use t. It doesn't really matter, but since they use t, I'll use t. T minus 65 squared. And that's all I need to do, because it says second degree. So once I have that squared, I've hit the second degree Taylor polynomial. Again, if you have trouble remembering the pattern, it's right 1, 1, 1. First derivative over 1 factorial, t minus 65 to the first. Right, next term, second derivative, so divided by 2 factorial, and then to the second power. And actually, that's how we get the first term too. It's divided by 0 factorial and x, or not x. And t minus 65 to the 0 power. So there is no derivative, right? The 0th derivative, so just the normal function, divided by 0 factorial to the power of 0, but anything to the power of 0 is just 1. So that's why that first term is, and 0 factorial is 1, so we're just dividing by 1. Come on. Okay, so that's why that first term is always just the function evaluated at whatever. Okay, so there's the Taylor polynomial. Now let's actually use it to approximate at t equals 85. So P2 of 85. W of 65 we know is 60. Plus w prime of 65. Now wait a minute, what is w prime of 65? We did that on like one of our very first questions. W prime of 65 is 8/5, and W double prime of 65 is this ugly thing. So I'm going to use those. So 8/5 divided by 1 times t minus 65, or actually, I suppose, actually, I'm going to do one thing before this. I'll go ahead and actually write out these values of just the general Taylor polynomial too. It's hard to say. I couldn't tell you exactly if they do care about that or not. Like if they would be okay just accepting this part, or if they want you to actually go ahead and plug in the values that we know. Let's see. W double prime of 65 was, what was it? negative 8 over 375. But then the negative 8 but then there's also this 1 over 2, right, from the 2 factorial on bottom. So actually this 8 and 2 would cancel to make 4. So I'm going to put negative 4 over 375. And then t minus 65 squared. This would, now that I think about it, this would probably be better. Since we do know these values, then I would say go ahead and plug those in. I don't know if that counts as like the simplification part or not. Okay, but now let's go through and actually 85, so 60 plus 8/5. 85 minus 65 is 20, so times 20 minus 4 over 375. 85 minus 65, 20 squared. Right? This part definitely on the BC test, just straight up leave it here. Don't worry about the fractions. Don't worry about spending the time to even punch it into your calculator. Right? Just leave your answer right here. If you so wanted. You would get this. Okay, so what does this actually mean? So remember, what this represents is approximating the number of workers inside the building at t equals 85. So W of 85 is approximately 1,316/15ths. So that's what we got. That's our last part, right? I just went through F. Yes, this next one starts a new question. So we'll come back and do the new question tomorrow. We'll go ahead and leave it off in here. So go try that Taylor polynomial, Maclaurin polynomial, PFA, or AFA, I think. AFA, yeah. It's available. I don't think there's a diagnostic for it, but go try it. Make sure if you haven't responded to my email that you please do that in the next couple days, like in the next 2-3 days. That'd be awesome. And again, I'm pleading with you that you're studying your formulas and practicing on your own. Okay? Like, you know, not to be negative here, but like this is something that you would just have to know. Like, not immediately, but maybe like, oh yeah, that's the average value formula. It's something that you've got to just be able to look at and recognize what it is. Okay, and it's just even just sight recognition of, so again, whether it's making flashcards for yourself of different formulas and things like that. Yeah, because that's, I mean, that would be like, for this part, that would probably be probably be like 1 of 2 points in this whole problem by explaining the meaning. So you'd have to know, oh, that's the average value formula. Right, it's the difference between getting 1 point and 2 points, which is huge. right, so again, we're coming down to it where there's like, less than 2 weeks until the first test date. I'm supposed to find out more information today. They're supposed to send out stuff. They might even be sending stuff to you. I'm not sure, but they should be sending stuff to me today. Hopefully I can tell you guys more about that tomorrow. Okay. But I hope you're spending a lot of time on your own working on this stuff, because this is the true crunch time. All right. Any other questions, comments? Glad to have the Abundance stream back. Yeah. Feels good to be back. Missed you guys. Okay. Keep practicing, studying that sheet, studying any formulas, okay, organizing your notes and things, getting things ready, practicing FRQs. Use the AP website YouTube channel. They stream practice sessions and FRQ type questions. That's put out by AP and College Board, so that's got to be relevant information. Go back and do old FRQs that we've done. All right, sit down and see, okay, I know Abundance told us how to do this, but can I replicate that on my own? That's so important. Repetition, guys. Constant repetition. All right, I will see you guys back tomorrow. All right. Have a good rest of your Tuesday. I'll see you then. Peace.